Hey guys, welcome to the video for factoring when a is 1. This is the first day where we're just talking about factoring in general. We're in Unit 6. Our essential question is, how can I rewrite a trinomial into the product of two binomial factors? So there's a lot of vocab going on here, right? So we're rewriting a trinomial, which is 3 terms, into something that is two terms. All right, so let's go over some vocab really quick before we even jump into today's lesson. So we haven't seen the standard form of a quadratic before, but I want to go over it. It is ax squared plus bx plus c, where a, b, and c are just numbers. They represent numbers. So normally when we see it, they're just regular old numbers. So a and b and c are always numbers. They're never going to be a variable, always numbers. Now with factors, we talked about what factors are when we list factors of 12. Those are two things that multiply to make the other. So 1 times 12, 2 times 6, and 3 times 4. So factors are two terms that multiply together to create a new expression. Okay, so I am going to be switching from here into my camera, and if I have to cut the video, it's just because I need to cut it. It's just too long, but other than that, I'm just going to warn you about just switching back and forth between the camera because I do want to show you what's going on with my calculator. Now, if you have not seen the factor by grouping or been in class for factor by grouping, this is not going to make any sense to you. So you need to make sure that you've caught up previously before you even try to attempt this lesson. All right. So we're going to review multiplying binomials. So binomials are things that we saw in Unit 1, but we haven't seen it really since. So I'm going to go ahead and talk about Unit 1's review of binomials. So here we have two binomials being multiplied. We have a binomial here and a binomial here. And the way we learned how to multiply these was we either did the box method or the pull apart method, and I let you choose whatever you wanted to do. But I do like another way better, and it is a little bit shorter, and it's called double distribution. So for example, if this x wasn't here and I just had negative 3 times x plus 5, what would you do? Well, you would just distribute the negative 3, right? Well, what if this negative 3 wasn't here and it was just the x? Then you would just distribute the x. So it's called double distribution because you're going to distribute twice. You're distributing two different things. So we're going to distribute the x first. So we have x times x, which is x squared, and x times 5, which is positive 5x. Then we have negative 3 times x, which is negative 3x, and negative 3 times, negative 3 times 5, which is negative 15. And then you want to look for your like terms. And our like terms are usually in the middle or sometimes on the outside. Well, our like terms here are 5x and negative 3x, which make positive 2x. So I have x squared in the front, so that didn't change, and negative 15 didn't change. So what did we do? Well, we started off with two binomials, and we ended with one trinomial. So we started with two things that were two terms, and then when we ended with one 3-term thing. So let's just talk about where all these things come from because we want to know, right? Well, where did that first term come from? I'm talking about this trinomial here. So the first term is x squared. Well, where did it come from? What did we multiply to get it? Well, we multiplied the first two things in our binomials. So we multiply the first two terms together. All right? And then the second question is, well, where did the last term come from? Well, this last term, which is negative 15, where did it come from? How did we get there? Well, we multiplied negative 3 times positive 5. We multiplied the last two terms together. So where did that middle term come from? Well, what's our middle term here? 2x. How did we get 2x? Well, we first had to combine something to get 2x. And then where did those two numbers come from? Where did 5x and negative 3x come from? It came from a combination of all four of those terms. So it's a combination of everything. So to find 2x was a little bit more difficult because there's a little bit more work for it. All right. So that's just kind of a review of multiplying binomials. So what we usually do is we start here and then we end here. But today we're going to start here and end there. Now you're like, how am I going to do that? Well, I'm going to show you. Before we do that, let's just talk about factoring, right? So remember, factoring is the opposite of distributing. Right? So distributing is multiplying. Factoring is we're basically dividing out. We're undoing the distribution. So we're essentially going backwards. So instead of starting here, I'm going to start here. Well, if I start there, what do I need to do in order to go backwards? Does this change going backwards? Nope. Does this change going backwards? Nope. This changes, right? This changes by basically being split up into two different terms. I'm basically uncombining the like terms, right? I had like terms, I combined them, and I got 2x. Well, now I have to undo that. So today we're going to learn how to undo that. But before you ever do any type of factoring, you always check for a GCF first, a greatest common factor, before you ever start. Because if you don't check for it, then you haven't factored completely. So you always want to check for that. Now, today's notes are factoring when a is equal to 1. So a is typically going to be 1 in this case. And it is going to be 1, not typically, it is. So in number 1, we have x squared plus 5x plus 6. Okay, well, let's check. Do I have a GCF? Is there something I can divide out of everything? What's the biggest number I can divide out of all of these? Just 1, right? Can I take out any x's? No. Now, is dividing 1 going to really change anything? It's not, right? It's going to keep everything exactly the same. So it doesn't even matter to divide out 1. So we're good. We checked for a GCF. The next thing is if I want to factor by grouping, how many terms am I going to need? Well, if I check back at my factor by grouping notes, I look, well, I have 4 terms here, right? In order to factor by grouping, I have to have 4 terms. And if I don't have 4 terms, then I can't factor by grouping. Well, right now, I only have 3 terms. So I got to get this to become 4 terms. Well, when I look back, if I want to go backwards, what do I need to do to get 4 terms again? I need to split the middle guy back up. So we're going to take our middle term and we're going to draw 2 arrows because we're going to split it up into 2 different terms. But it can't just be any 2 numbers. They have to be special numbers. And I'm going to show you how to do that. The first thing I'm going to do is I'm going to introduce you to the AC method. The AC method is called that because we have to do A times C. So I want you to draw a little bit of an X on your paper, not too big, not too small. You want to be able to write in it. Now, before we actually do the AC method, I want to show you where everything goes. So AC is going to go on the top of your X, and B is going to go at the bottom. So think about B standing for bottom. B will go to the bottom of your X. And then you don't want to put anything in here yet. Okay? Now, underneath the AC, if you want to, I would draw a little multiplication symbol, and above B, I would put a plus sign. Okay, and I'll talk about what those mean in a second. Before we actually even plug anything in, we got to identify what our A, B, and C are. So we're going to identify our A first. Remember, A, B, and C are numbers, and A is attached to your squared term. B is going to be the one that's attached to just the variable by itself, and C is always the number alone. So A here is going to be positive 1. B here is 5, and C is 6. Okay? So I identified my A, B, and C, and they're all positive. Now, the reason why it's called AC is because we're going to multiply A times C. Well, my A is 1, and my C is 6, and I'm going to multiply that and get 6. Well, what's my B? 5. Okay. Now, I got to figure out 2 numbers that go here, but they're special. And the reason why I have the plus and minus there is for a reason. I want 2 numbers that multiply to AC. That's why there's a times there, right? Because I want it to multiply to AC. And add to B. I want it to multiply to make AC, but add to make B. That's why there's a plus here. Now, you're like, well, how am I supposed to do that? Well, we're going to use our calculator to help us. So go ahead and write the steps down first. Now this trick is a little bit different from the trick you learned previously to find factors of GCFs. So this trick is just for using the AC method, so you don't want to confuse it with that. So in the first y equals, we're going to type in AC divided by x. And then the second y equals, we'll do parentheses AC divided by x, close parentheses, plus x. So last time you would type in all of your different numbers and divide them by x. This time, you're only going to type in AC and you're going to do it twice. Whoops. That was an alarm. Sorry about that. Hopefully that doesn't like hurt people with headphones. So you're gonna put your AC in that top part of your numerator. All right. Now you're gonna end up with a table when we go to our table, and it's gonna have 3 columns with numbers in them. Okay. You're gonna have an X column, a Y column, a Y1 column, and a Y2 column. You're looking for B in the Y2 column. Okay. And you're going to figure out what these 2 numbers are. These are our special numbers. And so we will get there in a second. So let's go ahead and try this in our calculator. Now, in our calculator, we want to type in AC on top, right, above our X's. So what is our AC in our first problem here? Our AC is 6. So that's the number we want to type in for AC. So I'm going to go ahead and switch to the calculator now. Okay. Turn my calculator on. Whoops. I'm going to go ahead and clear everything. So I'm on my main screen here, and I want to go to y equals first. And then I want to type in AC divided by x, which is what you wrote in the notes. So AC for number 1 is 6. I'm going to divide that by x. Now your x button is right here next to your alpha. You're going to scroll down and do parentheses 6 divided by x plus x. And now we want to look at our table. So second graph. Now remember what I showed you in the notes was that we're looking for our Y2 column. So in this red column, we're looking for the number 5. So remember, our B is 5. We're looking for B in the red column. Well, do I see 5 in the red column? I do. I actually see it twice. But regardless, it gives me the same numbers. What are the 2 numbers next to 5? 3 and 2. 2 and 3 are my magic numbers. I want 5 in the red column, okay? So if we go back to our notes here, I figured out what my special numbers were. My special numbers were 2 and 3. Okay, so in the calculator, this is basically what I saw. Right? I wanted to look for 5. And why am I looking for 5? Because that's my B value, right? This is our B value here. And when I saw 5, the 2 numbers I saw next to it were 2 and 3. So 2 and 3 are my magic numbers, and they're going to go on the sides of my x's. So what does that mean? It means when I split up my 5 here, let's go ahead and make these red. When I split up my 5 here, I'm going to split it up to 2x, positive 2x, and positive 3x. Now, why are they positive? Well, they weren't negative, so that's why I know they're positive. I'm splitting my 5 up. Now, does the 1x squared change? No, that stays exactly the same. And the positive 6 also stays the same. That doesn't change either. So we did all of that work just so we could split up 5 in half. Not really in half, but into 2 parts. Again, you can't just pick any 2 numbers, right? So 2x plus 3x makes 5x. So I'm basically splitting it into 2 parts, but I got to pick special numbers in order to do that. And that's pretty much the hardest part, because once we're there, then we just factor by grouping. So I also want to mention that it doesn't matter if you put the 3 first. So if you want to put the 3 first and then put the 2 second, that's okay too. You'll still get the same answer in the end, and I'll show you how it's the same. So now that I have my 4 terms, right, if I have 4 terms, I can now factor by grouping. So I'm going to split it into 2 groups. So in my first group, I'm going to look for a GCF. Well, my biggest number I can take out is a 1. And then my biggest variable I can take out is 1x. So I can take out 1x. So I take out an x. Well, if I have 2 x's and I take away an x, I still have an x left. 2 divided by 1 is just positive 2. And those x's actually cancel each other, and so I don't have x's anymore. Moving on, I'm going to do my GCF of the next 2. Well, the GCF of the next 2, the biggest number I can take out is 3. And again, if you need to use the calculator trick from the day before to figure this out, you can do that. So I'm going to take out positive 3. and 3 divided by 3 is 1, so I just have 1x, and then 6 divided by 3 is 2. Now at this step, what do you want to check for? You want to check to make sure your parentheses match each other, and if they don't match each other, you need to do this again to figure out what you need to do to figure out what you did wrong, right? So you need to go back and figure it out. You don't want to force it to match, it should just match on its own. So then we have x plus 3 times x plus 2. So we put our matching parentheses together and then our GCFs together. Now we did this on, all of this right here is from the previous day. So basically everything I just taught you from the beginning is the new stuff, and then this is everything old. So if you don't know how to do that, then you need to catch up because you're going to be kind of lost. Now what if you write it this way? Is this also a correct answer? Well, yes. It doesn't really matter the order, but we do want to make sure they're right next to each other because I'm saying I'm multiplying them. So I have x plus 3 times x plus 2 or x plus 2 times x plus 3. And I can actually check to see if this is correct. But how could I check this mathematically? Well, I could double distribute and I should end up right back here. So I go ahead and hop over to Desmos. Okay, I'm going to do x plus 2 times x plus 3. Now this is what a quadratic looks like. So we're essentially making expressions to make a quadratic. But what if you put the 3 first? X plus 3 and then x plus 2. Is there any difference between these two? No, they're exactly the same. And if I type in my original, x squared plus 5x plus 6, this is our original problem, what do you notice? They're all matching. They're all equivalent. So as long as you have red or blue as one of your answers for the factors, then you're good. You're all good there. All right, so let's move on to number 2. All right, first thing you do is you check for a GCF. Well, the biggest thing I can take out is a 1, and that's it, so I'm going to move on. Make my AC method. AC goes on top, B goes on the bottom. Well, in order to do that, I've got to identify A, B, and C. My A here is 1. My B is negative 1, right? We have 1 on the front and negative 1 second. And then our C is negative 12. Well, AC goes on the top of the X. What's A times C? Well, A is 1, C is negative 12. If I multiply those together, I get negative 12. My B is negative 1. Okay? Now I'm going to use my calculator. I'm going to type it in. What am I exactly typing in here? Well, here you want to type in AC on top, right? So just like the little calculator trick here, you want to do AC on top. So we have negative 12 divided by x, and then y equals negative 12 divided by x in parentheses plus x. And we're looking for on our table in this problem, now you don't have to write all of this. This is not work. This is what you're typing in your calculator. I'm just trying to help you out here. In the y2 column, what are we looking for? We're looking for negative 1. That's the number we're looking for, right? And we're looking for the two magic numbers to get us there. So let's go ahead, whoops. Let's go ahead and switch over and try to figure that out. All right, so I'm going to go back to y equals. And remember, just to get out of the calculator, you do second and then mode for the blue quit button. So that's how you exit out of any application. So we have y equals. Now in this one, I have... what number did I have? Negative 12 divided by x. And then I had negative 12 divided by x plus x. So I have those written, and I want to do second graph to go to my table. Now I'm looking for negative 1, because that's my B. I'm looking for negative 1 in my y2 column, in this red column. And I see that I have negative 1. Now sometimes you will have to scroll. It's not always going to be right there in front of your face. You will have to go look for it sometimes. So next to negative 1, right, in this red, I'm going to look at the numbers next to it. So negative 4 and 3. Those are my two magic numbers. So 3 and negative 4. Okay? 3 and negative 4. Those are the two numbers I want to put in the sides of my x. Sorry, my iPad messed up there. So I'm going to split this x into positive 3x and negative 4x. Is it wrong if you do the negative 4 first? No, it is not wrong. It is up to you if you want to do that. I do not care. So then we still have x squared at the front and negative 12. What the? Why did that turn red? Okay. Move that over too. All right, so again, we did all of that work just so we could split the middle term into 2 terms. And why are we doing all of this work anyways? Because I want to factor by grouping, and I can only do that with 4 terms, and I only had 3. So we're going to start now with factor by grouping. X squared plus 3x minus 4x minus 12. You do not have to write it again twice. I only wrote it again twice just so that when I have my notes, I can read them easier. All right, so we're going to split this in half. I already used green. Let's not use green. We'll use baby blue. Find the GCF. Well, the biggest thing I could take out of both of these is 1x, right? 1x, the biggest thing. And I'm going to go through this pretty quickly, not because I expect you to know exactly what you're doing, but I don't want to waste your time either. So again, all I can take out is a 1x, so that's going to go outside my parentheses, but I don't have to write that 1 there. It's not necessary. My leftovers go on the inside. And then I'm going to do my second 2 terms, my second group here, because I split it in half. Make this orange to match the previous problem. All right, so what's my GCF for these 2 numbers? Well, again, you can do your trick, but I already know it's going to be 4. But because the first term in our group is negative, you want to take out a negative 4. If the first term's negative, you take out a negative. It doesn't really matter if the second term is negative or not, though. All right, so negative 4 is my GCF. Negative 4 divided by negative 4 cancels, and all I have left is my x. And then I have negative 12 minus 4, which is positive 3. So those match each other. I want to make sure my parentheses always match each other. And then I put my GCFs in one parenthesis, so I have x minus 4, and then I have x plus 3. Again, if you have x plus 3 first, that is still correct, right? I showed you in Desmos, they're all equal to each other. They just, it doesn't really matter the order as long as they're present. Now with number 3, we don't have x's, we have m's, but you treat it exactly the same. You check for a GCF. The biggest GCF is 1, so we're good. And the next thing is we're going to do our AC method. And why are we doing that? Because I only have 3 terms and I want it to become 4. So let's go ahead and write our x. AC on top, B on the bottom, because B is for bottom. All right, so the first thing I want to do is identify A, B, and C. My A is 1. My B is negative 11, and my C is 10. All right, so AC, so A times C. What A is 1, C is 10. 1 times 10 is 10. Now A isn't always going to be 1, right? Our notes today is A is 1. So eventually A won't be 1 and you'll have a bigger number. Okay, and our B is negative 11, and I'm looking for 2 magic numbers that are going to add to 11, or negative 11, but multiply to 10, right? That's the whole point of this. Negative 3 and 3 add to make negative 1, but they multiply and make negative 12. Just like in this one, 2 plus 3 makes 5, but 2 times 3 makes 6. So that's what we're doing here. So you want to make sure that you're not just picking any 2 random numbers. So in the calculator this time, I would have y equals 10 divided by x, and y equals 10 divided by x plus x. And when I'm looking at my table, what am I looking for? I'm looking for negative 11 in my y2 column, because that's my b. Now, once I find it, I'm going to go ahead and do that in the calculator on my own, so I don't bore you with the whole calculator trick. 10, delete that. Okay. Once I do my calculator trick, I get negative 1 and negative 10. Again, you might have to do some scrolling. It's not always like really obvious what it's supposed to be. So negative 1 and negative 10. And let's see if it makes sense. Does negative 1 times negative 10 make positive 10? Yep. Does negative 10 times negative 1 add to make negative 11? Yep. So that makes sense. So we're going to split this middle guy into 2 terms. We'll do negative 1m and negative 10m. And then my m squared at the beginning stays the same, and my plus 10 stays the same. And so now once we're here, we just do factor by grouping. So again, I'm going to copy it down just so that when I have my notes later, it's just easier for people to read and they can see it. But again, you can start working from this point. You don't have to wait until the second here. All right, so we're going to split this into 2 groups. Remember, make sure the sign is still attached to your number there. Okay, so the first thing I'm going to do is I'm going to look for my GCF of the first 2 terms. it is going to be just 1m. So when I write it out, I can just write m. I don't have to write the 1. And then I have left over m minus 1. And then I have a GCF of the second 2. Well, I notice that that first term is negative, so I know I'm going to have to take out a negative number. So the biggest number that can go in a negative 10 and 10 is 10. And I can't take out any m's because this one doesn't have any m's. So I have negative 10, and then I have m minus 1. Do my parentheses match? Yes. So I'm going to put my GCFs together, and then my matching together. Remember, they are multiplying, so that's why we have them right next to each other. We don't want to write them on top of each other. And again, that's still the same thing as m minus 1 times m minus 10. I would still get the same exact thing. 2 times 3 is the same thing as 3 times 2, so it doesn't matter the order. All right, let's go to number 4. Can I take out a GCF? Nope. So then we check. I have 3 terms, which means I need to make it 4 by doing factor by grouping. So I'm going to draw my x, because I need to do my AC method here. And we're going to identify A, B, and C. My A is 1, my B is negative 14, and my C is negative 120. Now, negative 120 is a really big number, so I might have to do a lot of scrolling in my calculator to find my magic 2 numbers. So A times C is going to be negative 120, because 1 times negative 120 is just negative 120. And then my B is negative 14. Okay? So in my calculator, I'm typing in y equals negative 120 over x, and then y equals negative 120 over x plus x. And I have my 3 columns after I hit graph. And I'm looking for negative 1, I'm not looking for negative 120. I'm looking for negative 14, right? I'm looking for my B value, right? So you're using AC to type stuff in, but you're looking for the B. And you're looking for those 2 numbers that are going to make negative 14. So negative 120 divided by x, negative 120 divided by x plus x. Whoops. Second graph. All right, I'm looking for negative 14, and I see it. I got 6 and negative 20. Those are the 2 magic numbers I found. So 6 and negative 20 are going to go. Now, if you want to put negative 20 and then 6, that's also perfectly acceptable. It does not matter the order. You will still end up in the same answer. So we start off with w squared. We have plus 6w minus 20w. And then we have minus 120. All right, so we have, the only thing we did was we split up that middle 14, and we made it 6 and negative 20. So then we can start by factor by grouping. Again, once you get the hang of it and once it clicks, then everything is kind of just, you're doing the same thing over and over again. I'm going to split it into 2 groups because I have 4 terms now. GCF of the first 2 is w, and I get w plus 6. The GCF of the second 2 terms is going to be negative 20. I have to take out a negative because the first term in the group is negative, and then I have w plus 6. I put my GCFs together. My GCF of w and negative 120 go together, and then w plus 6. So that is that one. Again, it doesn't matter the order, so it could be backwards. And the only time it's backwards is if these are backwards, but it doesn't really make a huge difference. All right, so now I got a huge number, number 5, x squared minus 37x plus 322. So again, you check for GCF. You always do that first, no matter what, because if you don't get in the habit of doing that, you're going to forget to do it eventually. So the biggest number I can take out of all 3 is just positive 1, so it doesn't make a difference. Now I see that this is 3 terms, and I can find a way by maybe making it 4 terms by doing my AC method. So we're going to do our AC method here, AC, and B on top, or B on the bottom, I'm so sorry. Identify our A, B, and C. So we have A is going to be 1, B is negative 37, and C is 322. So A times C is going to be 322, because 1 times 322 is 322. Our B is negative 37, and I'm looking for 2 numbers that are going to multiply to 322 but add to negative 37. So in my calculator, I'm going to have 322 divided by x, and then y equals 322 divided by x plus x. And then in my table, I am looking for what number? I'm looking for negative 37, my B in that y2 column. So I'm looking for it. So I'm going to type this in the calculator, 322 divided by x, and then 322 divided by x plus x. I'm looking for positive 37, or negative 37 in the y2 column. So I'm going to have to do some scrolling because, again, 322 is a huge number, so you might have to scroll for a little bit. All right, I found it. So I got negative 14 and negative 23. And again, I'll show you what this looks like. So again, I'm looking for negative 37 in that y2, and I see negative 23 and negative 14. So those are my two magic numbers. Okay, so I have negative 14 and negative 23, and that's what I'm splitting my middle guy into. So negative 14x minus 23x. Since those are both negative, I want to make sure I both have negative signs there. X squared stays the same, and positive 322 stays the same. Now that I have four terms, I can factor by grouping. And again, if these numbers, since they're really big, you might have to do that calculator trick that we learned the other day. So you split it up into groups. GCF of the first two is just x. I know I'm going by quickly, but this is one of those things where I'm not going to waste your time by walking through it, right? You got to know how to do it, and if you need help, please come see me. GCF of the next two, again, you might have to use that trick. So the trick would be in the first y equals, right, in your calculator, you would do 23 divided by x, and then in the second one, you would do 322 divided by x. And then you're going to look in the red and blue columns to see what's the biggest number they have in common. All right, so the biggest number they have in common is going to be 23, but because that first term is negative in the group, I have to take out negative 23. So negative 23, so I would have left as x, and then 322 divided by negative 23 is negative 14. Do my parentheses match? They do. And so that means I did it correctly. That's your checkpoint, right? You want to make sure you did it correctly. And then once you're there, you have now factored it. We're basically going backwards. And how would I check that? Well, I could double distribute it and check it. So I would do, right, I would double distribute. X times x is x squared. X times negative 14 is negative 14x. Negative 23 times x is negative 23x. Negative 23 times negative 14 is positive 322. I have like terms, and those like terms become negative 37x. And let's check. Is that what I started this problem with? Yep. So I did it correctly. If you have any questions, please feel free to come in for tutorials. I will be happy to help with any questions that you may have.